Using Hess's law to calculate net reaction enthalpy, you need to be able to apply Hess's law. Okay, so we did that a while back in like chapter 4, I think it was, when balancing equations, like how to balance equations that happen in 2 or more different steps. And you need to be able to deal with multiplying enthalpy by an integer, or what happens to enthalpy change for a reaction for the reverse reaction. So make sure you understand those 2 concepts. Basically, if you reverse the direction of a reaction, you reverse the sign of enthalpy. If you multiply by an integer, you multiply delta H by an integer. If you divide by an integer, you divide delta H by an integer. And the key to balancing any kind of equation that happens in 2 or more steps is find the intermediate. An intermediate is something that's formed at the end of one step and then gets used up at the beginning of the next step. And that is your key to balancing the equation, because they need to cancel out. So when you are adding together equations that happen in multiple steps, for each individual step, everything to the left-hand side of the arrow is a reactant in the overall equation, and everything to the right-hand side of the arrow for each step, 1, 2, 3, however many steps you have, is going to be a product in the final reaction. So your intermediate in step 1, if you've got the same number of moles of that intermediate in step 1 as get used up in step 2, they will cancel out because there's a product and then it's a reactant. Boom, same on both sides of the equation, it's gone. Okay, and that is your key to balancing the equation. So we have to multiply everything in step 1 by 6 in order for that C2H2 to cancel out. So that means 6 calcium carbide. 2 times 6 is 12 waters. Can I just write a 1 in here? Let's try it. 12 waters, and then you're going to form 6 C2H2 and 6 calcium hydroxide. Okay, so what does have to happen to our delta H? Well, that minus 414 is going to be times by 6, so that is minus 2,484 kilojoules. Times that by 6 as well. So then we should be able to add everything together to get our overall reaction. So we're just going to make sure that that balances out. Okay, so overall we have 6 calcium carbide plus 12 waters plus, what I mean about the intermediate cancels out, 6 C2H2 plus 3 CO2 plus 4 H2O. Wait for it. I know we can simplify this. It's just like a math equation, right? So if the H2O was X and you had 12X plus 4X, what would you do? You just add them together and have 16X, right? It's the same thing with chemical equations. As long as they are exactly the same chemical species in exactly the same state of matter. So solid, liquid, gas, aqueous, iron versus neutral atom matters, right, for chemical equations. Anyway, onwards. 6C2H2. Yes, I know I haven't put the states of matter in, but have you seen how much space I've got on my screen? CaOH2 plus 5CH2CHO2H. I guess that's the acrylic acid, right? All right, so this would be my overall equation, and as you can see, we can tidy it up. 6C2H2 is on both sides, so I'm gonna cancel them, the same as if I had 6X on each side of the equation, right? And that 12H2O plus 4H2O, I can simplify to 16H2O. Now I can see what I'm doing. Okay, so that is my overall reaction. Okay, so then to calculate delta H for that overall, so delta H total, I'm just going to add together delta H for step 1, which I had to multiply by 6 to get minus 2,484, plus delta H for step 2. So that's going to be 1,248 kilojoules. Didn't do anything to step 2, so just bear in mind sometimes you might have to do something to both steps, like times 1 by 2 and 1 by 3, for instance. Okay, plus 132 kilojoules. Now this is going to give me delta H for this whole reaction as written. So it's 132. It's, oh, hang on. 248 minus 2482 plus 132 should be minus 2350 kilojoules. Okay, and that's for the whole reaction as written. And we are asked for the formation of 1 mole of acrylic acid. Now we have formed, if we look at our balanced equation, 5 moles of acrylic acid, CH2, CH2H. So I'm going to remind myself of that by just writing the per 5 moles of acrylic acid writing out in full on the bottom. So I've actually got to divide this through, in this case, by 5 moles. That won't always be the case. It's going to depend. You might only end up with one mole of product. I don't know. So that is minus 470 kilojoules for every 1 mole of acrylic acid. Okay, so just be careful with that. If you're asked per mole of some particular species, just check the balance equation that you should have worked out on your way to working out delta H for the total reaction.